Welcome back, Math 30-1. In this lesson here, we're going to look at the sum and difference identities. Okay, so here is a little exploration which I strongly encourage you to do. But for us right now, we're going to start on class example number 1. So it says it wants us to develop the identity for tan A subtract B using a similar procedure as above. So we're going to use this procedure here. I'm going to follow this procedure, and we're going to develop this formula here. Okay, so let's take a look. I'm going to start off with, we know that tan A minus B is the same thing as sine A minus B all over cosine A minus B. Okay, so now we're going to plug in my sine identity, my sine subtraction, and my cosine subtraction from our formula sheet. So when we're doing sine subtraction, we're going to use this equation right here. So I'm going to end up getting sine A cosine B minus cosine A multiplied by sine B all over. Now we want to do cosine A subtract B, which is this one right here. So cos A cos B plus sine A sine B. So I'm going to have cosine A cosine B plus sine A sine B. Okay, so we just follow the identities. We're following the steps here. So now that we have that, it wants us to divide the numerator and denominator by cos A cos B. Okay, so now we're going to divide both the numerator and denominator by cos A cos B. So I look at that, I'm going to have sine A over cos B minus cos A sine B, all divided by cos A cos B. And this is going to be divided by cos A cos B and I want to plus sine A sine B all over cosine A and cosine B. Okay, so now I'm going to separate these into their different addition sentences. So we have down here, let's move this a bit more, we're going to have sine A cos B all over cos A, cosine A, cosine B. These will cancel off, and we end up minus, and it was cosine A sine B all over cosine A, cosine B. And here these will cancel off, and this is all over. We have cosine A cosine B all over cosine A cosine B, which is nice. These will cancel, and this is plus sine A sine B. And this was all divided by cosine A cosine B. Okay, so now when we simplify this, we are left with sine A over cos A. And we're going to subtract sine B over cos B, over cosine B. And this is all over. This here cancels off to leave 1. And here we're left with sine A cosine A, so that's going to be 1 plus tan A. And sine B over cosine B is the same as tan B. Those are multiplied together. And this part here is the same as tan A, tan B. So we end up getting, for my final step, we'll get simplified tangent of A minus tangent of B all over 1 plus tangent of A times tangent of B as my answer. And that is exactly what we get for the a minus b right there. Okay? So we just kind of showed you how to do that there. Now for classroom example number 2, we're going to look at what are going to be more or less more similar to questions you will see. So here it says express 15 degrees as a difference of two special angles. So 15 degrees is kind of the same as 45 minus 30. It's equal to 15. Now we want to look at sine 15 degrees. So then we could say sine 15 is equal to sine 45 subtract 30. Okay? Now this is a difference, so I'm going to look at my formula sheet here and go all the way over. We have a difference, so we're going to use this law here again. So I'm going to have, this is equivalent to, see that there, we're going to have sine A, which is 45, cosine B, which is cosine 15, or cosine 30, all subtract cos A, which is cosine of 45, and multiplied by sine B, which is sine 30. Okay? Oops, put that right there. So now let's simplify these out. Now that I have this, we're going to simplify this out, and I'm going to end up getting sine 45, I'm going to put it underneath, is the same thing as root 2 over 2. Cosine 30, that's the longer cosine, so it's going to be root 3 over 2. And then we're going to have to subtract here. Cosine 45 is root 2 over 2. And sine 30 is short, it's 1 over 2. These are multiplied together. So this is going to give me root 6 over 4. Subtract root 2 over 4, which is simplified to root 6 subtract root 2 all over 4. And we're going to leave it like that because that's exact form. Okay? So let's take a look at class example number 3. It says we have 5 pi over 12 as a sum of two special angles. Okay? So now we have 5 pi over 12, and we know that cotangent of 5 pi over 12 is equal to that there. Now, for some of you it might be easier to first convert this to degrees and then find what sum equals that and then convert back to radians. But right here, I'm just going to go straight into radians. I know that pi over 4 plus pi over 6 is equal to 5 pi over 12. Okay? Now, we want this in cotangent, so that's going to be the same thing. I'm going to look first here now at tangent, because it's just going to be the reciprocal of our answer. So I'm going to say tan, and we're going to have pi over 4 plus pi over 6 is what we're going to look at. All right? So we're going to have to use my tangent one, and it is a sum. So in that case here, I'm going to be looking at this formula right here, and I'm going to plug in everything into that formula. So that's going to be the same thing as tan. We're going to have pi over 4 plus tan pi over 6 all over 1 subtract tangent of pi over 4 multiplied by tangent of pi over 6. Okay? So I continue this here. Pi over 4, that's root 2 over 2 divided by root 2 over 2, because that's my x and y, it's going to be 1. Tan pi over 6, that's the same as 30 degrees, so that's going to be my my short y divided by my long x. So then root 1 over 2 divided by root 3 over 2 is going to be plus root 3 over 3. And here we're going to have 1 subtract, and we have 1 times root 3 over 3. Okay? So this here is the tangent, but I want to know what cotangent is. So I'm going to have to take the reciprocal of that for cotangent of pi over 4 plus pi over 6 is equal to, we take the reciprocal, 1 minus root 3 over 3, and we have 1 plus root 3 over 3. Okay? Now, we don't like these fractions within a fraction, so I'm going to multiply all my denominator by root 3, and all my numerator and all my denominator by root 3 over 3. So that's going to end up giving me the same thing as root 3 minus 3, or sorry, minus 1. And we're going to get root 3 plus 1. Okay? And if I want, I could multiply by the conjugate and try and get something more fancy, but this is good enough for now, and that is going to be my answer in exact terms. All right, so now it wants us to simplify the following. So I have sine 100 and cosine 100 minus sine 100 or cosine 100 sine 100. So to solve this one, I'm going to see which equation does that look like. So we have sine cos, subtract cosine. So sine cos, subtract cosine is the same as sine A minus B. So this here is the same thing as sine 100 minus 10, which is the same thing as sine 90. Now, the sine of 90 is equal to 1, okay? Because that's going to be 90 degrees is right there. So it's just going to be equal to 1, and that is my answer. Let's take a look at this next one here. This one looks very, very messy and complicated, but it's not that bad if we look at it. If I want, here we have cosine, quarter pi minus this, and cosine. So we have cosine, cosine, sine, and sine. Okay? So cosine, cosine, sine, and sine, and we are subtracting. So cosine, cosine, sine, and sine subtract. So that's going to be cos A plus cos B. So this is really cos A plus cos, or A plus B. Okay? So here, if I look at it, this is my A, and we have this here is my B. Okay? So this is equivalent to, I have cosine 1 over 4 pi, and we're going to minus theta. Then we're going to plus 1 over 4 pi, and then we're going to plus theta. Now I look at this here, these thetas minus plus cancel off nicely, and this is going to be left with pi over 2. So I'm going to get cosine pi over 2. So 1/4 is half a pi. So pi over 2, well, I look at that there, that's the same as 90 degrees, so this is equal to 0. Okay? So my x value is 0 there. Alright, now question number 5 says, we are given cosine of A is equal to 3 over 5, cosine of B is 5 over 13. So let's first look at cosine of A, and we want to find cosine of A plus B. So we're going to first look at cosine of A and where it is. So we have 3 over 5, and A is between 0 and pi over 2. So we're in quadrant 1. So my radius is 5, and my x value is 3, and now we want to find my y value. So my y value here is going to be 4 because of our Pythagorean identities. So sine of A is going to be equal to, we have here, 4 over 5. Okay? So now we're going to do the same thing with my B. So we're looking at cosine of B. Now, it's between, right here, 3 over 2 pi and pi. So it's going to be in quadrant 4. And I know this part here, my radius is 13, and my x value is 5. So if I did this with the trig, or with a Pythagorean identity, I'm going to know this is 12. 12 squared plus 5 squared is equal to 13 squared. So we know here sine B is equal to 12 over 13, and that's negative because it's in that quadrant. Okay? So we want to find the exact value of cos AB, so let's write in what is cos AB here. So I know cos A plus B is equal to, so go back to our formulas, we want cos A plus B, we're going to be using this one here, so it's cos A cos B minus sine A sine B. So we have cos A cos B minus sine A sine B. Okay? Now, what is cos A equal to? Cos A is equal to 3 over 5. Multiplied by cos B is equal to 5 over 13. Okay? Minus sine A is equal to 4 over 5. And we have sine B is equal to negative 12 over 13. So now I'm going to finish multiplying this out. These cancel. So I'm going to be left with 3 over 13. And this is going to make this plus. And I'm going to be here. Oh, nothing really simplifies there. So that's going to be the same as 4 times 12 is going to be 48 over 5 times 13 is 65. Okay? Now, I want to add these together. And I am going to end up getting the same. I'm going to end up getting, this has to be multiplied by 5 to get that. So we're going to get 15 plus 48 is going to give me 63 all over 65 is going to be my final answer.